Let us assume that you want to start a new clock manufacturing plant in India. You're thrilled about it because you believe that it's going to be a cash cow. However, your rational mind instructs you to conduct a quick investment analysis to determine whether you will be able to recover your investments or not. And for doing this type of analysis, you would typically start with the internal rate of return or IRR. However, IRR does not always work when the cash flows are non-conventional in nature. That is, cash flows turning positive and negative and then positive again and again during the project life. So this is where MIRR or modified internal rate of return comes really handy. Hi all, my name is Dheeraj and in today's video we'll discuss all about MIRR, its calculations, how it helps to address the limitations of IRR and its uses. So let's get started. So before we look at the discussion of what is modified internal rate of return, I would presume that you know what is IRR or internal rate of return. If you are new to this concept of internal rate of return, then please do have a look at this very comprehensive video which we have made on IRR. It will tell you what this means, its calculations with step-by-step instructions and examples. Okay. Now, why do we really use MIRR or modified internal rate of return? The primary reason is that your internal rate of return has lots of limitations or problems. So once we understand what those problems are, it will be easier for us to understand the concept of modified internal rate of return. So let's understand the IRR problems first. The very first one, that is basically there is the problem of multiple IRRs. So multiple IRRs usually come when there are non-conventional cash flows. Okay. So what do I mean by non-conventional cash flows is, let's take an example. Let's say, there is this $5,000 of initial investment in year 0 that you make. And then in year 1, you get let's say $15,000 in return. And in year 2, the cash flow again turns negative. So from negative to positive and then it turns to negative, let's say minus 10,000. So this is a non-conventional cash flow. A typical conventional cash flow would be like, there's an initial cash outflow, which will be a negative sign, and then you will have positive signs across the year till the project ends. Okay, a non-conventional would be minus, plus, minus, something like that. Okay, so in this case, what happens is that there are multiple IRRs. So what do I mean by multiple IRRs? The solution, the mathematical solution to this will result in two IRRs. So let us calculate the IRRs here. So I'll use this formula called as IRR. And this will expect the values. These values are like 5,000, 15,000 and 10,000. And then we need to provide a guess. So let me provide a guess of, let's say, 15%. Okay. So what do we get as a solution? We get the solution as 0%. So IRR is 0% in the first case. And let me try again. Values. And this time, let me guess a higher number. Say, for example, 55%. And what do I get? I get IRR of 100%. So as you can see, I have two IRRs, right? Now let's assume that the cost of capital of the project is 10%. Okay. So what would you do in this case? Would you select the project or reject the project? So if IRR is 0%, we would reject the project. And if IRR is 100%, you would accept the project, right? But here we are getting conflicting answers. So this is the biggest problem of internal rate of return. It doesn't work in the case of non-conventional cash flows. Now, let us look at another problem with internal rate of return. And that's extremely important before we move to the modified internal rate of return. Now, the problem here is regarding the reinvestment rate. Okay, I'll explain this in a bit detail with the help of an example. Let me create an example first. Okay, let's say there is a 3-year project and let's say in initial year, the project requires an investment of $200. Okay. In year 1, let's say $100 is the cash inflow, 150 in year 2, and let's say 200 in year 3. Okay, so let's calculate the IRR first. So how do we calculate IRR? Use the IRR formula and values and put a guess, right? Let me put 5%. So what do we get as return is 47%. Okay. Now, as I said, reinvestment rate is a problem with respect to internal rate of return. I'll just explain that in a bit detail. Now, what does this mean is, in this project, we are getting 47% as a rate of return. Obviously, this is a very high number, correct? Now, when we calculate IRR, the implicit assumption is that whatever the cash inflows that we get year over year, they are reinvested at IRR. Now, imagine you getting $100 at the end of year 1 and you're reinvesting it at the rate of 47%. Obviously, let's assume that in year 0 today, you just got hold of a massive project, a big project and very exciting project, and you were able to get this kind of a return. But do you know that you will be able to find another project which will generate 47% returns on that $100? Quite unlikely, right? So this is the limitation of internal rate of return. Likewise, subsequently, when you look at year 2, it's again assumed that this 150 will again be reinvested at 47%. So this becomes a very optimistic, rate of return that is expected from the future cash flows, right? So that's the biggest limitation of internal rate of returns, and it seems like it is not the right approach to look at. So sometimes what happens is it's kind of, overestimates the rate of return. So that's the limitation of IRR. So in order to address these issues of multiple IRRs and overestimation of rate of return, we use something called as the MIRR, or modified internal rate of return. So what happens in this modified internal rate of return is that, when we have this project, let's assume the same project. So in this case, the reinvestment rate, which was earlier 47% in the first case, here we will assume some rational number. We might not assume a very high number as high as 47%. Now, what could be the expected rate of return the company can expect? Usually the company goes for the cost of capital. Now, this is the minimum amount that the company is expecting from its projects, right? So this $100 which you will get in future, obviously it should earn at least cost of capital, right? So we assume that the rate of return is at least cost of capital. So now let us understand how do we calculate MIRR, or modified internal rate of return. Okay. So for that, we will require what is our cost of capital. So let's assume that the cost of capital is, let's say, 10%. Okay. So in order to calculate MIRR, the very first step we need is the present value of cash outflows. Okay. So what is the present value of cash outflows here? That is $200. Okay. So that's the first step. The next step is to calculate the future value of cash inflows. Okay. What are the cash inflows here? $100, $150 and $200. These are the cash inflows. We need to find the future value. That is the value at the end of year 3. Okay. Now, in this case, our assumption is that $100 will be reinvested at the cost of capital, that is 10%. So we have to find the compounding effect of this $100. That is how much that $100 will be in the future. So it will be like this: 100 multiplied by 1 plus 10%, that's the cost of capital, to the power of 2, right? Because this between 100 and 200, we have 2 years, right? From year 1 to year 2 and year 2 to year 3. So this is 2 years, right? So it gets compounded twice. What about this 150? So this will be equal to 150 multiplied by 1 plus 10% to the power of 1, because there's only 1 year left for between year 2 and year 3, right? So the future value of cash inflows will be 200 plus 121 plus 165. Okay, so this is our future value of cash inflows. So How are these two related, 200 and 486? Basically, what's happening here is that 200 is growing at the rate of MIRR every year. That is, it's getting compounded every year at the rate of MIRR, and it becomes 486 at the end of the third year. So the equation becomes something like this: 200 multiplied by 1 plus your MIRR, or the modified internal rate of return. And since there are 3 years from year 0, right? 1, 2, and 3. So it becomes to the power of 3. So this will be equal to 486. That's what we found, right? So primarily what we have to do is now to find out MIRR from this mathematical equation. So here we can divide this 486 by 200 so that, we will have 1 plus MIRR to the power of 3 on the left hand side. So in order to solve this 1 plus MIRR to the power of 3, we have to first remove this to the power of 3. So in order to remove this, we'll have to find the 1/3 root of, this 2.33. So this will be 1 by 3. So we will have this as 1 plus MIRR. So essentially MIRR will become equal to 1.34 minus 1, and that is equal to how much percent? That will be equal to 34.4%. So the project's rate of return when we use MIRR sounds more reasonable, right? As compared to when we used IRR approach. 47% was pretty high compared to 34.4%. Obviously, when we look at MIRR, you might say that, okay, the calculations are very difficult. It's like a mathematical problem. What happens when, let's say, the number of years is like 15, 20 years, then how will we solve this mathematical equation? So don't worry about that, because we have a shortcut. We can also use the mathematical function inbuilt in Excel. So like we had earlier in the case of IRR, we use this IRR function in Excel. You can similarly use the MIRR function in Excel. So let me use that, and it will be very easy to use, in fact. So the key input is MIRR and the brackets open, and you need to just provide the values, right? So the values are like this: 200, 100, 150, and 200 here again. So what's the finance rate? Basically, finance rate is the discount rate that you have assumed. So here you will find there are two things, right? Finance rate and the reinvestment rate. So cost of capital is basically your finance rate. So I'll just have it linked here, and you can assume the cost of capital to be the reinvestment rate, or you can also assume a different reinvestment rate. So here in our case, we have assumed both to be the same, right? So in this case, I'll link it to the same thing, okay? Here you might also want to assume a reinvestment rate of, let's say, 5% or let's say 12%, depending on your management's expectation. But this is how you can easily calculate MIRR. Next step is just to press enter, and what you get is the answer which we got earlier, that is 34.4%.
As we conclude today's discussion, a big thank you to everyone who tuned in from the Wall Street Mojo team. But hold on, the financial adventure continues. The next episode unfolds on Tuesday, and we're super excited about what's in store. Make sure to subscribe and turn on those notifications so you don't miss out on the financial insights coming your way. Until next time, this is the Wall Street Mojo team signing off. Stay informed, stay engaged, and stay Wall Street Mojo awesome.